our students, we treat rate of chemical reactions, rate of chemical reactions. By chemical reactions, we mean the chemical or the transformation, the process that transforms a set of chemical substances into another set of chemical substances. So you have two elements coming together, then to interact and result in the formation of a new substance, or an element and a compound, or two compound or more compounds coming together, they chemically interact and then give rise to a new substances, so which are entirely chemically different from the starting substances. So we call such a process a chemical reaction. So a chemical reaction is a chemical change, a change where a new substance is formed. It is like when you have hydrogen and oxygen gases coming together, they react, they interact, and then produces, water. So that is a reaction, a chemical reaction. So, and how do chemical species? When we say chemical species, we mean any chemical substance, be it element, uh, a compound, or any molecule. It's a chemical species. So, how does a reaction take place? So we have, the chemical substances reacting together, which we call the reactants. We call them the reactants. So when they come together, they interact by their particles. So every chemical species is made up of particles. So the particles are in constant motion, whether these substances are gases or solids or liquids. So when they come together, there must be, because the particles are in motion. So when they are mixed in the reaction system, then they collide. The molecules, the particles collide with one another. They mix up, they collide with one another until they achieve what we call effective collision. Effective collision. So the collision theory that guides these processes specifies that there must be an effective collision before a reaction can occur from that interaction. So when they collide, the collision must be of highly energetic enough to ensure that that interaction result in reaction. So for you to have a reaction, then there should be formation of product. So the particles that are reacting, they are the particles of the reactant. So when they do so, they give rise to what we call the products. So the new substances forms are called the product. So an effective collision is required for such to happen. An effective collision is that collision that is, sufficient enough to bring about a reaction. Then aside effective collision, the interaction, there must be a development of an energy. eh, Enough. There must be the molecules, they must possess energy which is enough to overcome what you call the activation energy. There is an activation energy. So this activation energy is the minimum energy required for a reaction to occur. You understand? So for a reaction to occur, this minimum energy must be met. So the interaction must be accompanied by an energy greater than the activation energy for the reaction to occur. So these two are very important requirements. Effective collision, then overcoming the activation energy for a reaction to take place. That is a chemical reaction. So, like I've mentioned, the chemical substances that come together to undergo the chemical reaction are called reactants. Then what they form called the product. So, example, when we have hydrogen gas reacting with oxygen, giving water. So, hydrogen and oxygen are both reactants, and this is the product. So, some reactions involve coming together of two species to give to produce one product. When two species comes together, they produce more than one product. For instance, When we have sodium hydroxide and hydrochloric acid interacting, they form sodium chloride and water. So two products coming together to form two products. In some reactions, only one reactant is involved. One reactant breaks up, that is decomposition reaction. It breaks up and forms two or more products. You understand? So that like when you have your calcium tricarbonate 4, when it decomposes, it forms calcium oxide and carbon 4 oxide. So this in cement production we call this reaction calcination, whereby calcium carbonate at certain temperature of let's say 800 to 900 or 900 to 1000 for instance, it breaks up, releasing the free line and the carbon 4 oxide. So this is the thermal decomposition reaction. So this is an ordinary direct combination reaction. So we have different types of reactions. So reaction could involve one or more reactants, and the product could be one or more products. You understand? So usually where we normally have one product is when in direct combination. We have elements combining with elements like hydrogen and oxygen, it forms one product. So that is it. Then the topic, which is rate of chemical reaction. We are talking about rate of chemical reaction. We're talking about how fast does a reaction proceed. So when we're talking about reaction, reaction can be very slow, it can be very fast. So how fast or slow is a reaction? It's what we call rate of chemical reaction. So at what rate is the reaction occurring? At what rate is the what do I call it? The reactant, at what rate are they changing into the product? Or at what rate is the product being formed? Because in a reaction, the reactants are disappearing as they are disappearing into the products. While the products are appearing, they are being formed. So the rate of a chemical reaction is the rate at which the reactant is disappearing, or the rate at which the product is appearing, or the amount of the reactant that is disappearing with per unit time, then or the amount of the product that is being formed per unit time. So that is rate of chemical reaction. So this rate can still be mathematically be defined to be measured in terms of the change in the concentration, the change in the concentration or the number of moles or the number of moles. So this stroke is actually or. Okay, let me put or. So it will not look like I'm dividing. So the change in the concentration or the number of mole of the reactant or of the product all over the unit time, the time required for such change. That is all over, let's say, change in time. So when we divide the change in concentration within a certain time interval, you know, by that time interval, for instance, in a rate of reaction in an experiment, when we're trying to determine the rate of reaction, so we start with a certain quantity of the reactant, then we take note at time zero. So after some times, let's say after 5 minutes, then we check again and then take note of the amount, whether in concentration or in the number of mole of the reactant that we have. Because for the reactant, since it is disappearing, the quantity, the concentration or the mole will be decreasing with time. So when we take how much has gone at a particular time over that time change, that is the rate of the reaction. So that if you're working in concentration mole per dm cube and a time in second, then the unit of the rate of reaction will be mole per dm cube per second. So this is the rate of reaction. How expression of the rate of reaction mathematically it could be in terms of the change in concentration over change in time, or change in number of moles over change in time. So that is rate of reactions. Like I said, reactions rate, why do you have to be involved, constant with how fast or slow a reaction occurs? It's very important for us, especially for the industrial chemist who is into production of chemicals like your soap, your petrol, many products, chemical products that you have. They are obtained from certain chemical reactions. So they need to the target of an industrial chemist is to produce you know a certain product, and at he has a target of quantity of what we call yield. He's looking at the yield of the reaction, how much he wants to obtain per unit time. So how much he wants to produce per unit time. So he's interested in that. He wants to improve the yield as well as the quality of the reaction. So the rate of reaction influences the rate, the yield. If your reaction is too slow, then what are going to be able to achieve, the quality of the product you produce in a day, for instance, it's not going to be much compared to when if the reaction is fast. So if you understand the rate of reaction, then you can play around it, manipulate your reaction to occur faster than it would be naturally. So you should know all the conditions that can influence your reaction rate. So that's why it's very important because some reaction is very slow. Some reaction can take years to complete, can take months. For instance, rusting of iron is a very slow process. There's some explosive reactions are fast. So the reaction will have different results. That's why it's necessary to study the rate of chemical reaction. And then we now go to a very important thing, what you call factors affecting the rate of chemical reaction. The rate of chemical Factors affecting rate of chemical reactions. So let me check my recording.